high-tech systems. But of course, for us here, the manufacturing industry is by far more interesting. And that, of course, also relates to the high-tech industry. So here again, the definition, how we talk about digital twins, the points that they mirror aspects of real system processes and products, and that they are connected to live data feeds. And therefore they monitor, they assess, and they predict the behavior of the physical twins with their own computations. And all of that is then going into the business processes. All these parts you will see again today, so that there is something which mirrors, that there is something about the connection, that there is something about the business process. All of these parts have to be in place for a successful digital twin. And I cannot stress the importance of the business processes enough here, so that if you just say, I have a digital twin, and your understanding of that would be that the SME using it just has more data, it might very well say, okay, certain decisions are made more accurately, more timely, maybe even, but it will most likely not live up to the full potential of what a digital twin could offer. That would only be true if business processes reflect the new reality, reflect the reality that now you have this data as your fingertips, that different people can act in different points in time on that data, on that information. And therefore, a change of business processes is part of the change of digitalization with digital twins. So with this, of course, we had to start with the why. We had to understand the business of the SME we are talking to come up with the purpose, so that we can indeed also say that the investment into the digital twin is justified. Now, the compass tool, which I showed yesterday, developed by Laura together with the rest of us, that is very much about the business purpose. But of course, it already had these parts about how difficult might it be, how big is the gap between a company and the digital twinning process. So in that sense, the level of digitalization was already investigated here, but today we will see something like this a little bit more in detail. So that would be about the return of investment, but then of course the investment itself, why is it big? So potentially big. It's probably not as big as buying all the machines for a new factory floor. So don't get me wrong in this regard, but it is an investment. And it is especially an investment for an advanced digital twin. And I think after today's presentation, you will understand that, why we think about it in this way. The point, simply speaking, is a digital twin is in itself a system, which now connects to a different system, the physical twin. But being a system means it is developed. And development efforts are always an investment. So yes, there are solutions which make this easier on the technical side, but it is still very important that whoever wants to use the digital twin makes sure that the digital twin is doing the right things in the right way, in the right timely fashion. And that is system engineering. And that system engineering effort will always be there. And the quality of the system engineering process translates into the quality of the digital twin, its fitness for its purpose. So in that sense, it is an investment, even if maybe the money involved in terms of buying things might be rather small. It might very well be that it can be done with open source tooling, that technical infrastructure is mostly available and all of these things. But you still require time of expert to make it do what you need to do. And that is, it will always be an investment. And this is why starting with the why to justify this investment is mandatory, but understanding which investments will follow is also important. And that is basically what this day is about as well. Now, the first part had the compass tool. You have that one down now. And well, with the purposes, I already explained to you that the digital twins which come out of a certain purpose will look differently. And here on this slide, you actually see already a little bit of an example that even if you just looking at the data dashboard, you might see very, very different things. So in the middle of the slide, these two graphs, the left, all these bar charts, things like that, that might be about energy consumption, values where you just say, okay, I need it on an information, I don't need to act on it. On the right side, on the other hand, you do see a match between a certain system's behavior and other system behavior that were observed in the past. And based on the match, you make a prediction, for example, the remaining useful life of a system. Now, here it's easy to see that the graphs and the thing look differently, but the data, the computation that was used to generate the graph is very, very different. The picture to the left can in principle be in an now and history kind of view, while the one in the middle is making a prognosis. It tells you, based on what I have seen in the past, this is what I predict will happen. It's a match. That's a more complicated computation. So out of a sudden, I have techniques in place which belong to the field of data science, which might not have been necessary on the left side. So here it means on the computational axis of things, we needed different technology to build something like this, which of course means we are building a different digital twin with different tools. I explained to you yesterday that all of this is of course part of a journey and that the journey has its own needs too. If you're interested, we have a nice flyer in regard to this that goes a little bit into the details here. But also, again, I urge you, especially from the point of view of a digital innovation hub, to embrace this idea. It is a transformation. A transformation means change. It means we want to be in a different place that we were in the past. And therefore, this picture of a journey is appealing. You might find a better one that works better for you personally. This one works for me very well. But the points that a journey has its needs, that you have to think about how to do it and to take the people with you, that is very, very important. And I think a digital innovation hub is in an excellent position to give consultancy on these aspects as well. They are not technical aspects. They are about culture. But in that sense, you might know the bon mot that culture eats strategy for breakfast, meaning if the cultural aspects go wrong, all the technology strategy that this is how we are going to build will not succeed. Either they will fail completely, or at least they will not be as successful as they could be. So if I would think about, if I can only change one thing, the culture towards a better way of working with a better understanding of the people in a company or the technology, then I would assume actually that the culture is more important. But well, TNO is an organization of applied science. I'm in a rather technical division of TNO. So of course, I speak mostly about the technology, and that is where the Change2Twin readiness is indeed playing its field. Now, in that story, I told you yesterday already that we developed these 7 steps to digital twins. So let's look at it a little bit. The 7 steps of digital twins, which are described in that brochure, which I just mentioned briefly. You can find it on the ESI website, by the way, the link is here. But of course, we also make it available via Change2Twin. Now, that 7 steps methodology basically says these are your attention points for realizing digital twins. You start with the why, and we covered that. The next point is to select the assets. So basically that is the physical twin. So what is the twin about? Now, asset selection might be very straightforward in many cases, but maybe it's actually not. Next to that, infrastructure. So that means the technical side of things like data transport, data storage, all of that is infrastructure. But then that doesn't mean you have a twin. It just means you have a data stream. So twin building, what does that mean? It means that there's a model, for example, inside which says, well, given that this data comes in, I make that prediction. That is what we mean with the twin building. It's the computational side of the digital twin, the model and the computations that work. But then the twin goes live. That, of course, has its own attention points, the live operation, which always should be connected to a business action. Like I expressed earlier, things will look different in a company that has a digital twin at its fingertips. And well, at least it should look differently. So linking it to business action should always be part of the process towards a digital twin, thinking about how tomorrow business processes will look like. And then there's a point of cradle to grave. If you have the impression that you build a digital twin once and then for the rest of the time you will never ever touch that one again, well, you might be right, but in that case you would also be extremely lucky, because most of the time this is not true. Most of the time, just with any kind of system that you are used to, be it your smartphone, your computer, or your factory floor machine of the SME you are advising, change happens. So there will be upgrades, there will be updates, there will be new tasks. So what then? That is cradle to grave. The full life cycle of the systems has to be covered by the digital twin and how to do that. The last part I would like to point out, so 6 and 7 are very often overlooked. If you go to a tool vendor, they might easily go up to 5 and then it stops. I ask you, be better than that when you give advice. Now, let's go into the details here. Asset selection, the physical twin. Now, I stated digital twins mirror aspects of real systems, processes, or products. Now, the examples given of these slides already show you that might be quite different. And of course, systems, processes, products, that's absolutely not the same thing. So it might be the logistics chain of a factory that gets a digital twin. It might be the processes on the shop floor, but it might also be the equipment on the floor. So the machines producing the product, but it could indeed also be the product itself that has a digital twin. For example, if the purpose is about the quality of the product, which I might address with the digital twin of the equipment, seeing how well calibrated it is, and whether or not there are wear down effects that affect the quality of the work the machine is doing, from which I guess that most likely if the machine is getting on the verge of being, let's say, in a shaky condition, it will most likely not produce good products. But of course, I could indeed also take data measurements from the product itself and have an online quality control in, let's say, the old-fashioned way. Of course, everyone in manufacturing knows how that this is, principally speaking, something that you do. You inspect, but then the digital twin says, okay, let's do that. Let's twin the product. Let's take inspection data to find out what is going on here, whether or not there is a decline of the product's quality over time and things like this. So let's do it with more data point that a visual inspection, for example, would have ever been possible. But let's talk about the product. So all of that could be the asset that the digital twin is about. And when you think about the asset selection, then of course it's a little bit the point about what is the most critical point that you want to do. And only when you have that, you can talk about the infrastructure. So when I know that it's about the product, then obviously I need other sensors than if it's about the machine. And if it's about my logistic chain, then who talks about sensors in that sense anyhow? It's not that I have a sensor reading a temperature here. No, it's that I have a digital twin that is getting data from my logistic partners who tell me that now the delivery that I'm expecting in my logistic chain is on the way, and maybe even give me tracking information to see if there's any kind of hold up. So depending on my asset, I bring different sensors live and I enable alternative information flows. So in that sense, I have to think here about, given a physical twin, what are the sensors? What is most likely then the IoT infrastructure to use? Then I have to think about the data distribution principles. I have to consider items like, is this a push system? Is this a pull system? Is this time-based? So of course, also there are open standards and everything, but there are different ways. And if I have something where I said this is for crisis response, then I might decide that certain messages need an extremely fast response time. And so maybe a data collection once an hour would simply not be appropriate. So for this decision of an infrastructure, I think about the purpose again. I think about what kind of sensor data comes in and chose the correct data distribution principles. Cyber physical, the next part is the question whether or not we are actually connecting information bases, databases from the internet, for example, or from information systems that the company owns towards these sensor things, or if they stay separate. And then, of course, there's the trusted data sharing, because most likely all of this is not in an isolated place, in a silo where you say everything is within one company. No, there might be the partner, there might be a supplier where you pull data in, and then of course there has to be a way to say, okay, we can share this data and we trust that we protect each other's data. So it becomes a part of all of that infrastructure building itself. Now, on the physical side, that gives you the infrastructure, but of course the realization of the digital twin also has the other side, that you say, okay, how do I actually build the virtual side of it? So virtualization, what is the model of the physical twin? An analysis of failure modes and effects of their criticality might very well play a big role here, especially when it's about, for example, the machines on the factory floor. Then you have to have the link between these artifacts, which you see in these analyses, and the data. So it might very well be that someone is very good in analyzing what might go wrong in the machine and therefore should be monitored. But that's maybe on a higher conceptual level than the actual raw data coming from the sensors. So someone needs to make that link, say, wait a second, that data item relates to that concept. And these 5 data items need to be aggregated into that information, which then can be used in that way. Now, that is the data knowledge link. And sometimes this is in an area called data engineering as well. If it gets complex, you might need an expert for that one as well. Sadly, that will not be easy to find someone, but that's about that area. The next step here, ensure fidelity. When you have this link, of course, you also actually need to see that there is a good relationship between the physical twin and the digital twin. So in that sense, ensure trust. This digital twin is a system, like I said, so treat it accordingly. If you would be in system engineering, you would always assume that you have a validation and verification part in your system development process. It's the same thing here. Make sure the digital twin monitors reflect the aspects of the physical twin that are important in an accurate way. So think about that someone has to test that, and that someone has to understand what is important and how to see whether or not there are deviations which are acceptable, because there will always deviations, or whether or not it is back to the drawing board because something is fundamentally wrong. And next to that, there might be configuration management. If, for example, you say, well, I'm twinning 5 machines on the factory floor, they are all of the same type, but their maintenance status is different. For example, maybe they are using different software because they are doing different jobs, so they have a different configuration. So obviously then the digital twin, if it monitors and assesses aspects of these machines which relate to these differences, well, then also the digital twin needs to have that kind of configuration management that you can deal with these differences. Might not be so, but in the case that differences and different configurations are important, configuration management for the digital twin will simplify things. Personally, I believe this will be most important for everyone in any fleet situation. So if, for example, you are saying I'm running a fleet of cars, maybe car sharing, and I actually want to detect things like fraud and predictive maintenance so that I really have them on the road as long as they can be without breakdowns, things like that, then of course you want to build a twin once and roll it out to all of the cars, but then you still have to account for the differences. So making that right, having a core physical twin in all the cars, which is then looking into the details based on different configurations of the cars, different maintenance schedules or something like this, that would be the configuration management. Now, the next step is then operating the digital twins. So the live operation of the digital twin basically means it's always on, at least as long as the physical system is on, and it should always be in sync. Now, when I say it's live, I say it's always on. That doesn't mean it has to be an update frequency here in the seconds or something like this. It could very well mean once an hour. I know of one example where the digital twin actually now and then is connected to a hard drive working on collected data of several months in a very special situations where a live connection simply is physically not possible. So there might be differences, but principally speaking, the digital twin is running when the system is running. And the analysis, on the other hand, that is something where you say, okay, when is it actually needed to do something? When you do have a descriptive twin, a digital twin that informs someone about what is going on, then ask that person what update frequency they need to be in the picture. Maybe it's something where in the morning when I go into the company, I want to have a big dashboard in front of me saying, yes, yesterday was a good day. There's no crisis I need to respond to. So fine. Digital twin business of today concluded. I got my update. But it could very well be that you are monitoring a production process with the digital twin. And the digital twin is about process control, and the process is fast. So a detection of any deviation from how it should be, that should always be running and update me the minute, maybe second, it is possible to detect this. That also means that the detection runs autonomously. No one presses a button to say, let's check if the process is running. No, it always has to happen. But that doesn't mean that everything of the digital twin always has to happen. If you see at the little boxes here that you say, that I have on the right, I mentioned the descriptive twin, which is about what happens. Now, the process control twin might be an acting twin. It computes a response. It says, I have live monitoring, I detect a change, and I have a process control component which says, well, given that change, these are the knobs I'm autonomously turning now to get the process back under control, to see that we are not running into a disaster here. And you might indeed say there are more advanced data science algorithms inside here, like the anomaly detection. But then someone might say, okay, we had that crisis yesterday and the process control responded and the crisis is resolved, but we don't know why it happened. So someone might say, I need an assessment of the behavior of the system. What went wrong here? What is the root cause of my problems? I might need reasoning for this. Now that is possible in certain digital twins if they have these components available to them, if their computational power has them. But that is not something which is normally running always. It might be computational expensive. It might simply be that it's a complex problem where you want to involve a human, and that human, of course, is not always on that kind of task. But if there was something which justifies this investigation, the digital twin is able to help with it. But that is then reasoning on demand. There are special functions which are triggered by interactions with a human. So the live operation might have had these parts about the monitoring, the detection, maybe the process control, but not the reasoning parts. Which, of course, also links then in the business action. So the connection to be ready to reap the benefits of the digital twin, or to turn it in these words, the processes that consume the information. Now I gave you examples here. The process control is actually such a consumer of information, as is a root cause analysis. Then if you're doing that, there's a human who is the consumer of that information. And that, of course, means that the business should have a process, a person, whatever, to actually do that. So having the anomaly detection, but no one to hit the button to stop the machine if it goes out of control, no process control that would do that automatically, none of that, just means that you could have known that something goes wrong, but you didn't see it because no one looked, and therefore things went wrong and the digital twin has no benefit at all. So in that case, it's pretty obvious that you need that kind of process. But think a little bit deeper here. If information becomes available earlier in detail, that actually empowers people. It might mean that an engineer which was formerly now and then called to analyze a crisis can now actually say, now and then I just look into these data streams and into the anomaly detection, and I myself, with my power, with my brain that is excellent in recognizing patterns and figuring things out, I myself realize that we have an opportunity to fine-tune the system in certain directions. But that means, of course, the person now is doing something that they didn't do in the past. It wasn't possible for them. So it's a new business action. And thinking about what could that new business action be is part of digital twin building in the broader sense, in the 7-step sense. With all of that, of course, there's also the point of access the success of the digital twinning. Ask actually what are the criteria here, and you heard in the video of Laura as well, already some points here that many of these items can be expressed with the KPIs that the digital twin is there to improve. However, it could very well be that the success criteria, let's say, are on a slightly finer level of detail than these business-driven KPIs we spoke about yesterday. So it could very well be that the success assessment is measured quite, a little bit differently, but it could also be that it is a perfect match. If the digital twin is there to reduce downtime of machines on the factory floor, then okay, that is a KPI, end of the story. And if the downtime doesn't go down, well, then either these are factory machines which are unpredictable in their failure behavior, or the digital twin is not doing what it was supposed to do, which means we have to make it better. And therefore, access the success. Don't just assume because someone built it, it will do its job. No, investigate that. Now, in that sense, think about two very different scenarios here as well, whether or not you are controlling a system with the digital twin or not. This is very much related to that. I think the examples make it clear that there are these two types of digital twins, the ones which are catering to business aspects more, and the others which cater to system control or system analysis. And the system control aspect, that is shown in this picture. That's an interesting item. When you say there's a system, we monitor it, we analyze what we see, we plan according to the analysis, and then we have an execution of the plan in the operational context. Now, this is, in our eyes, the most advanced form of digital twinning, because the digital twin becomes part of a system control loop and is not separated from the system, looking at the system, but changing the system's behavior as well. So that's a special class of live operations and business actions that the digital twin becomes part of the system. And if you're in the business of building those, then you are definitely very, very close to novel kinds of system engineering. This is an advanced field where I believe we will still see a lot of progress in the upcoming years. Now, the last part, which I wanted to mention, is step number 7, the cradle to grave. So keep it alive and keep it useful. Here I give you the model-based engineering diamond. So basically the idea that in system engineering, you have the design and the delivery of a system that is the so-called V model, but that the digital twin is actually complementing the V, which goes down with the modeling and analysis part on top of it. That these two, of course, connect to each other via the digital thread. And in that sense, you have the concurrent development of the digital twin and the physical twin. And at the end, when you say, here's my system, you also have the digital twin, you have the models, you have the analysis, you know how everything relates to each other, but then you don't stop. You accept that change happens and you keep it alive, which means there might be an update. And here's the thing. It might very well be that with the digital twin, you find out that the system is not working very well. And because of that, you make an update to the system, which of course then implies that the digital twin will also need to change to reflect the new reality. It might be that your analysis showed you that the world changed and therefore the predictions of the digital twin are no longer accurate. Your system doesn't get an update, but the digital twin gets one. Or it could be that in a completely unrelated fashion, you found a need to update the system, maybe even physically, maybe just on the side of software, maybe because of new regulations, maybe because of something being broken, doesn't matter, but there was a need to update or upgrade the system, and then again the digital twin is no longer accurate. It is no longer fitting to its physical twin because the physical twin changed. So it needs an update. So in that sense, there is a continuous effort to keep a digital twin alive and useful. However, that might look at, oh dear, extra costs, that's bad. It's actually also quite an asset, because with the digital twin technology, with the digital thread that weaves the traceability of these items together, you have knowledge management. You basically have the information that this system runs with that and that uptime at that and that place, with that and that software version and these hardware components in that and that configuration. All of that information is out of a sudden there. And if you have long-running systems, this becomes crucial. So the moment you are talking to engineering firms like Raytheon, which none of you will do here in Europe because it's a United States company, but they, for example, are companies for infrastructure systems. That means a lifetime in decades. A lifetime in decades means, hey, I need to update that system. Who please build it? Oh no, that engineering team, all of them already in retirement. Sorry, we don't have the knowledge any longer. We don't know how the system looks internally. We cannot upgrade it. That's no longer allowed to happen. Customers will actually not accept that. So a company needs to know the state of their systems and how it looks like, without saying, okay, now I have to do a reverse engineering of my system to know what to do, because I might not be able to just replace it, even though in that situation, without knowledge management, might be the cheaper option, but your customer will still be unhappy. Therefore, the companies need that information. And with the digital twin and the digital thread, they should very well have it. So in that sense, accept that change happens and be prepared to work on the digital twin and the system from cradle to grave. And all of that goes into these core activities now. You see the full picture. And we are basically considering these the most important building blocks for digital twinning. Now, I spoke for quite a while now, and it's a complicated picture, but I think it is also clear that not all twins will need all of that. So in that sense, in this picture, there are certain pathways, certain pieces that you need. So a dedicated set of core activities, and they relate to the purpose, to the starting point of the company you're advising and the goals of that company. So the pathway then express the need. So if like this picture shows, the purpose of my digital twin is the monitoring of the optimization of a certain machine, which might run then in this ship, I need the colored boxes, but I don't need the other ones. So that's a certain pathway. And I can basically say, okay, as long as you have the competence and the technology to have these building blocks in place, don't worry about the others, just build this and you're good to go. That is what the pathways are about. And with this presentation, which of course is also then available to you, I list here a certain set of pathways where we said, okay, these are good examples, but please consider you are an expert here in the help of an SME. So the moment you understand the building blocks, you might very well say, I think this is the right pathway for this client. So take it again as an example, as an inspiration, but consider you're the one working with it. And if you say, okay, he said smart systems when a system adapts the control, so the highest order of digital twin in that inner system loop. And he said, yes, usage profiling, prediction, all of that, behavior assessment, all of that is part of it. Yes, it might be, but not for this client. And of course, you are then right to say that if you understand your client and understand the business here. So fine. But still, the pathway for the smart system is the high end in many aspects here. But there are others. If it's just about the virtualization on the way to a product, when it's about going digital, model-based system engineering, virtual design, simulation, and analysis. So all the customer engagement part of it, so that, for example, the customer gets to see what they could get in the order process, play around with it a little bit, see, let's say, the key performance indicators of the future system before it's built according to their wishes. Well, obviously, this is very much about this small part here centered around virtualization, data knowledge, FMECA with the digital thread. And we are actually not talking about a live data stream at all. So, well, you heard us, my colleague Jeroen and me speaking about digital twins. Well, this is the digital model. We would, by a hard definition, not call it the digital twin, but of course you will see customers who asked for that. So understand then there is also that demand for virtualization, which disregards the data streams completely. Another pathway is just that online point of I developed it, I carry it to the customer, I install it at the customer sites, I hit the on switch, and now this thing needs to work fast. So that is, for example, the commissioning process. And that might be light installations in a big office building, and every small detail that you do wrong, then out of a sudden press the button in my room and the light goes on in the living room. What is going on here? Okay, misconfiguration. Commissioning has to get these things right. And so first time on is first time right. That is very much about the match between this is what we want to have in the digital model, in the digital twin, it is expressed, but this is the physical system. So then, of course, fitness, configuration, fitting to environment. So if there is a certain configuration of the building, then of course my digital twin has to reflect this, all these things. So in that sense, this pathway here works as verification and validation process. And it can do that with live monitoring using data, or it can do that with tests, running certain scenarios or something like this. But again, it's not necessary to have certain components, prediction, change detection or stuff doesn't play a role here. It's a dedicated digital twin to have a certain phase in rollout to the customer under control. So another pathway is understanding this install base. Now, this is completely different from what I described earlier. This is my systems out in the field, and maybe I built a few hundred or a few thousands, and my engineering department says, how are my systems used? Are they actually using all the features that I built in? Are they running the systems close to the edge? Do I need more buffers in certain areas? Maybe they are constantly running hot and they are aging too much because of that. And I could have extra cooling if I just would know. So feedback to engineering. Dedicated analysis of issues, usage patterns, effects due to configurations. That's very interesting. If you have different configurations in the field and you learn that a certain combination of extras always causes problems, then of course you just tell your customer that that combination of features is not available unless of course you figure out how to fix the problem. So that is about improving what you have and understanding what you will build in the next generation. And again, it's a different pathway, different from the others. So could be a different purpose, ending up with a different pathway. The live processes, that's the pathway when fast response is essential, live view on ongoing processes, control based on live data, alerts on issues, events of interest. So everything that helps me to optimize my system, to schedule my actions, and to actually inform me if something goes wrong. So you could say this pathway is a very classical hardcore digital twin that might go up to a level of I have a dashboard and I'm aware of everything that is happening, and maybe indeed the first levels of automated response process control in regard to that. Now, the pathway for guaranteed availability. So when you basically have to have preventive maintenance, diagnosis, smart logistics of repair parts, all of that, addressing the point that an unscheduled downtime is not acceptable. So you just say you have customers that pay you for availability of the machine. So no breaks down, minimal service time, and when the service team comes to fix something in the machine, they have the parts with them, they have the expertise, all of that. But then, of course, that includes understanding the causes and effects of things that go wrong. So maybe the machine went down with a certain symptom, but the root cause is in a different part of the machine. So that should be understood. This is why root cause analysis is in this pathway. So you see here, it has a direction that includes prediction and reasoning, at least data science or AI-based techniques. So it's a little bit on the smart side here, but not so critical in the control side, for example. So all of that just drives the point home, I believe, that digital twins differ in the building blocks that they use, depending on their purpose. And now, of course, that brings me to the last part, the readiness itself. So the idea is that we want a quick process towards the right digital twin. I would say within the tool, you have a streamlined experience here. You assess these sections, which you see here on the picture. So whether or not a company has asset selection, whether or not they are ready for that, whether or not they are ready to build information flows, live operations, twin fidelity processes, all of that. And also some question about culture. So that is what you assess. And then on the other hand, we have the pathways for the main purposes. And then, of course, the tool is able to match that. So just a little bit like you saw yesterday in the Compass tool, we are saying, well, that is your readiness level in the area, for example, of digital thread, fidelity, and live operations. But for the purpose that you want to build the twin, these readiness levels are important. and there's a gap. And therefore, this is what you need. So that kind of thinking you can do with the tool. However, that is also something, if you are really tech savvy here and you say, well, in principally speaking, in our digital innovation hub, we can build these things, all of that. And I understand my SME customers so well that I know how their readiness compares to that and what they need and what they don't need, then this is absolutely an excellent option as well. So a little bit like with the Compass tool, take it as an advisor, take it as something that helps you, or maybe that makes sure that you don't overlook something. But be ready to say my own expertise is at least as good as the expertise of the people who wrote this tool. And well, with all the tools, have to use them right anyhow to make the best out of it. But to explain you a little bit more what the tool is then actually doing in terms of these matching, it compares numbers. And these are the same levels that you have seen yesterday. So digitalization levels, which are, let's say, fitting a little bit to their respective area. So if there is a pathway, that is not only the meaning that, yes, these building blocks are important, it comes with the meaning that you have to be on a certain level in that area, which of course makes it a lot more complicated to say, yeah, okay, it's a long list of things, but for that pathway in that building block, I only needed 2, while in that pathway for the same building block, I might need a 5 or something like this. So this is how the pathway are defined. And then, of course, this assessment, the readiness level of the company, which gives us the same set of numbers. And then we do the data analysis and we conclude where the needs of the company are. So this is under the hood of the tool. So we invested in getting a good idea about the necessary readiness levels of the pathways. And you are then in the assessment investigating the readiness levels of the company, and the tool does the delta analysis for you. Now, just like yesterday, the inspiration for the readiness level follows the smart industry digitalization levels. So the way to digitalization starts from the left, computerization, connectivity, but the digital twin part for the smart industry really starts with monitoring, understanding, predictive capacity, and adaptability. So I gave you an interpretation of this now to the right, especially in terms of, for example, processes and documents and things like that. So that manual work, of course, means there's nothing digital. And adaptability translates to there are automated processes that change life operations. The system, the process is adaptive. It responds to change and to events. So, and that is the kind of level thinking for the whole assessment. So 0 to 6 goes along these lines. So let's focus on the ones that are interesting. 3, digital processes and live data view. That just means it becomes available, while 4 is then already a process that consumes the live data, maybe to do something interesting in it, like process control would be the typical example. Now 5, a predictive process that consumes the live data. So there is some component inside which is not purely speaking responsive against a certain set point according to what it sees right now, but that is able to say, I see the trend here, I'm certain this will continue in that way, therefore we need to change something now before we run into troubles. And then, of course, it would just maybe be informative. It would be something like, for example, the preventive maintenance, that you are informed that that machine will go down within a week. Most likely, it's just a probability for that these things. And then someone is actually starting the process to say, okay, that means we are scheduling maintenance activities with the client and things like that. So there's a process that consumes the live data that handles an event that would happen in the future. Now, number 6, automated process, changing the live operations. That, of course, is pretty much in the domain of the smart systems. But even my example from now with the predictive maintenance could be something like this. It could be that the part ordering, all of that is automated, and that the downtime of the machine to repair it is automatically scheduled in the factory production plans and all of that, which would in that sense push it towards number 6, from level 5 towards level 6. Another view to look at this is that with levels 2 and 3, you have awareness of things and a human in the loop acts. With 4, but then increasingly with 5 and 6, you have automation. The response to what you see is within the business or twin processes. That doesn't mean that then cannot be a human looking at it or something like this. It just means that certain things can be handled with an automated process, giving it speed, giving it reliability as well. In any case, when you do the assessment, of course, there are attention points here as well. The one is an interview might need replies from several stakeholders. Now, this is a little bit different from what you have seen yesterday with the compass tool. With the compass tool, you can often say with an SME that there is someone at the helm of the company who can actually answer nearly all questions. They just might in some points say, well, yeah, I don't have the data right now, but I know exactly who to call now into the room to get this. Here with the 7 steps assessment, it would be typical that you would need several people. There might be someone who handles the data processes of a company, while someone else is looking at indeed the business processes. Typically, the first person is by more technically inclined than the second, and you need them both. You need them at maybe for some questions even at the same time in the room so that they can discuss this together, how things fit together. Afterwards, anyhow, you might say, now it's a set of people, and in certain companies, we see that it might be possible that there is something, let's say, a very strong chief technology officer who could indeed says, no, I got this. But if it gets into the detail, if the company gets bigger, it might be indeed several stakeholders. Another attention point is that we observe a trend to overestimations in self-assessments, that they actually consider themselves to be stronger than we would believe they are. So, like with the compass tool, ask, why do you think you are on that level? Explain it to me. Give me examples, and then I guess you will have that feeling whether or not they are really there, or no, let's put this one level lower. So, and another point is that the tool checks against the minimal readiness level for success. Optimal benefit might very well be one level higher. So basically saying below that level, we don't see how you can succeed for that purpose. But if you go higher, more things are possible. So consider discussing that if someone gets an assessment saying, hey, you are nearly there, that you say, yes, but you can always do more. So then take it as an opportunity to think, what if you would be one level higher? Now, with all of that, I'm at the end of the presentation. I will step over to the live demonstration of the tool in a moment. But of course, please be very welcome to ask for extra information, either me or my colleague Peter, for example. And then basically, just like we said yesterday, also with the compass tool, if you see reasons to improve the tool, then please inform us. Tell us what you think of it. Tell us what was useful for you and where you say, well, if it would be like this, then it would help me more. So now, one more sip of water. And if you understood the concepts so far, then I will just go to the tool itself. I do see there's a question in the chat. Let me see if I take that. Wow. Okay. Please allow me to park that until I have shown the tool, because I actually require a moment to pass that. I think the assessment tool itself, your understanding of that one would not be hampered if I just go on and we deal with that after the demonstration. So my browser window should be up now. The Change2Twin readiness assessment, you do see the address in the browser line. It's the same as yesterday, just with /readies at the end. And it actually also starts quite similar. You have this nice button of new session, which you need to press. You have your knowledge partner data, meaning your data. You have the tag for the session, and again, please use test if you're playing around. And then you have the SME information. And now, just like with the other tool, and it also, of course, comes with the data protection statement. And Laura explained that, I explained that yesterday, so it's mandatory. And especially here, again, you're looking into a company, so please, it's about trust in that sense. Now, when we go on continue, we go to the current status level, and there it actually gives you this picture about the 7 steps approach. It's in that brochure, which was also on the slide. So that you have these 7 steps. It is giving a brief explanation. It shows you again what the levels are, just as a reminder, and it makes it clear that you should start with the why. So we assume clarity on the purpose of the innovation, the why and the KPI it addresses. And if it's not the case, go to the compass tool. Stop in this moment. We need it. So, and now we actually go into it. So current status is the game of the play here, and we go through all these items. You go for asset selection, which was then the next step. And here you basically then see such an, how do I call that, tuned list of these levels I spoke about. So in the presentation, I gave you the general flair about digitalization numbers, but here in these multi-choice selections, you basically have an tuned version of that. So what would be the 0? The equivalent from pen and paper, it would be that from all the assets the SME has, they have no clue what is business critical, what the twinning should be about, because they don't actually know how anything relates to their business processes and their KPIs. Now, hopefully no one is in that state. If they are, they need a different kind of help. But let's just assume that they have the numbers. They know, for example, that a certain machine causes, when it goes down, that and that amount of money per hour, so they want to reduce the downtime, and they compared that for different machines on the factory floor, and so they have the understanding that this is important for them. Now, if you figure it out together with them, it's a have the numbers. If they did an extensive data-based analysis here, then it's level 4. We can go on to decisions on the prognosis of future needs. So that would be interested. So yes, it's not about the digital twin doing a prognosis, but their level of decision readiness here is then a 5. They say, yes, I not only have the numbers of my machines right now, but I also know next year after a certain extension and expected business or something like this, how it will affect all of that. And well, number 6, decision with automated processes, unlikely that we will ever see that for asset selection. So again, you get small explanations most of the time that you say, yes, statistics of unexpected downtimes, for example, they do exist. So I have numbers. Now then about the infrastructure. Here you see different asset selection just had one level. Infrastructure basically says I have 2. And this is also why the overview slide spoke about, what was it? I think 11 areas instead of 7. So infrastructure, are you ready to tap into your sensors, technology and process readiness? So for example, they say, yeah, well, we do have a live view. We, for example, have dashboards. Could very well be that that dashboard is on a machine. It's, for example, not connected to anything, and it has no annotations in terms of understanding quality or something like this. It's just raw data which is displayed something. So again, you get different levels here from 0 to 6, which are fitting to the infrastructure question. I'm selecting that live view of data is possible, and I'm selected the level number 2 for the question of the information infrastructure. So, for example, I had an event that a machine overheated. And now I have to ask, what did the machine do in that moment? What was the ambient temperature in that area where the machine is standing? And so on and so on and so on. So different pieces of information are important for solving what was going on. They are from different sources. And yes, level number 2, it says, yes, there we do have them. They are connected, but they are still in that sense individual, that, for example, there is not a synchronized view where you say, yes, all the time axes, for example, aligned with each other. No, that didn't happen. They are individual data sources, and maybe they have a different time granularity or something like this. But someone who knows how to use data sources, maybe just even in Excel, can figure out what was going on at that point in time. But it's not a sync live view for these different sources in one connected dashboard, and certainly not complex event processing that actually gives me something like, because this and this and this happened at the same time, that happened in that place, and after that happened, we were in that situation. So something like this, not at all. Then here comes something interesting, data governance. So how are data items handled? Is there someone who has the hand on that, who sees for consistency and things like this? And do you have more advanced information, things like information protection and stuff like that in the infrastructure already? So after that, we are already going to the twin building. So can they realize the digital twin core model? So this is about, do you have models on the processes to build models? So maybe you have certain things and you have a model-based analysis. So there is a certain tool which gives you one piece of an information, and there might be a different tool that gives you others. I think Benjamin actually had that as a nice example yesterday, that he stated indeed that for different purposes in his engineering processes, he indeed had specialized tools. So the past starting point of theirs is that level of twin building for their own products. Model-based analysis, and of course the results from one can go to the other, but it didn't have, for example, propagation of changes. I changed something in this tool on that model and it informs another tool that now the design is changed and certain things need to be recalculated and stuff like that. It didn't connect to data, simulation and predictions models. That is a different level from descriptive models. And then, of course, automated model generation processes, where at least all the boring stuff is taken away and done by the tool, pretty advanced stuff. So in my examples, I don't have that. And the next step, very often overlooked, so expect low numbers here, the fitness of a digital twin. So process maturity to check whether or not the models, the data, all of that you are building is fit for purpose. Well, isolated aspects, yeah, we have an idea, then we, for example, manually look into whether or not it throws out a prediction for that preventive maintenance. And now and then we ask the service engineer, was it really necessary? And they tell us, yeah, it looked a little bit worn. It was good that I was there. So that kind of tests, but it goes on higher levels. And you see again, higher order functionality. So for example, when the physical twin and the digital twin went out of sync, when you notice that, when you have live monitoring, next level, can you localize why? Is it the physical system that is changing? Or is it the environment that is changing? Why is it happening? Is it possible to predict that right now the twin is still functioning, but in 3 weeks when this degradation continues, you will definitely have to have a new digital twin version. So the people responsible better start now. So that kind of stuff. And again, automated corrections to counter degradations of a digital twin, maybe relearning of part of the model. Pretty advanced stuff. Don't expect to see a 6. I would argue like that. If they have that, they will not talk to you because they are done. So then live operations. Can you operate a digital twin to full effect? And then they might say, okay, again, I have connected information in digital processes. So yeah, I have a starting point, which is fair, but my processes are not fully digital. I have no live data view. So yes, I'm at level 2. Fine. And again, this is now close to the examples I gave earlier. Processes that consume the live data, processes that change the live operations would be level number 6. So, and then next to the live operations, can the digital twin feed a lasting change? Well, in this case, definitely not. They have digital documents, but no digital processes. So, no. Simply speaking, it has no impact in that sense, which of course also helps us with the business action. Is your business ready to act on the information provided by the digital twin? And again, we are at a company that is at the beginning of it, connected information and digital processes, but again, no digital processes that consume that information. And then the cradle to grave is most likely not better. So is there the digital thread? Can you trace the information? Can you know, for example, that For that point in time, that was the digital twin model. It was generated with that data. That was the observation period, things like that. So that's a maturity question. And again, our company here is on the low end of things. They have documents, but for example, they don't have change management with live updates, which would be a higher order of things here. Oops, sorry. And then can they keep the twin alive? So that is, do they have development processes which handle this quick update if something changes? One of the key terms here is DevOps. So that's again digitalization maturity in that specific area, whether or not you have a pipeline of development tools and process steps which quickly see to it that if the need to update was detected, a new version is generated which fits to the configuration where you need it to fit in and things like this. And well, of course, then with my example company, yes, we have something digital, but also isolated development procedures. So no DevOps and things like that. And then I'm asking about the culture. So is the company ready for this journey, and is there support within the organization? And so again, you get an tuned list here. No, we didn't even talk about this. Isolated stakeholder wants this. Maybe there's an early adopter community supporting this, or management commitment is already there. But then there might be companies where they say, no, everyone knows we need this. It's evident and communicated. It might be that they already know, hey, this is how things will change for our company as that stuff comes, and everyone knows how to prepare, which training to do and stuff like that. Or really, hey, we are all in this together, and we all work on this level number 6. So yeah, I would prefer not to handle a company on a level number 1, but then everyone has their starting point. Anyhow, we continue to the future digital twin. And again, a reminder of the purposes. And then you have here basically these check marks where you say, okay, which purpose am I talking about? And you select one now. I mean, you can select more, but the tool will tell you, hey, you selected 2, and I will give you the assessment for 1. Of course, in principle, we can have an overlay of more than one purpose, but it's harder to understand then why do you tell me that I'm not ready for this if we mix this up. So if you have more than one purpose that the customer wants, just run it twice here. I selected here that the company just wants monitoring of a system's operation. And then you actually see that in this case, you have certain options. So they want to detect if there are changes, and definitely whether or not there are anomalies to which they should respond. But the moment you're thinking about my building blocks, these two, that are 2 different building blocks. The one is a trend analysis. Are you out of certain boundaries? Is a question which is on the borderline between these two, but anomalies, the rare event, requires a different kind of algorithms to run. This is why things are separated, and that of course goes up to, I want predictive work in my monitoring. But you see the other purposes, you select them, you have them from the compass tool, so this is where it goes on. So, and here you see that warning, selected purpose is monitoring, warning, you selected one other purpose, so that you just know, okay, preventive maintenance will not be taken into account now. And then you hit continue, and this is what you get. For the monitoring with change detection and anomaly detection, we concluded that your current readiness level is like the red bars indicate, and the necessary gap is indicated by the black line, and in 2 cases you hit the mark, like I explained earlier. That means minimal. One here with next to live operations are stuff like feedback to engineering. Well, actually, you don't need it at all. But in many others, you actually want to have a readiness level of 4, 3, or here even a 5. And you're not there. So there's a gap. So, and this is it. This is the end of the analysis. So just like with the compass tool, this is in that sense the dashboard that you are getting. It's a lot simpler because it really has just this one graph. But on the other hand, it has all these areas below it where you then have to dive into and saying, okay, the analysis tells me your information infrastructure is 2 levels below. So that means we have work to do. So, and then the real advice starts. You go, for example, to the marketplace of Change2Twin and you say, okay, what is actually available now for information infrastructure? And well, listening to yesterday talks, you actually heard something. Yeah, there is something. So there's a framework that could probably help me here. So let's look at it. But maybe your innovation hub has indeed something different where you say in this areas, this is what I advise because I understand my customer. In any case, the same thing here, submit and save to image, just like you have seen with the compass tool. You submit the data, and on the other hand, you get the image to share with your customer and everything. Now, and that concludes the readiness assessment demonstration. Like I said, all of that is, of course, available to you. So take the time to read the information, play around with the tool. It will be useful for you to get an inkling about what the company needs. And if you prefer to have that in very long conversations, remember that I said this is an absolutely valid option. The tool is a streamlined experience in that direction. It allows you to go after it quickly. But if you are into a long-term partnership with the SME you're advising, then of course it is also very powerful to actually really go into the details here with them and to understand that. Now, with this, I'm at my end. I already have that one question in the chat. I will read it now in detail and try to answer, but otherwise, please questions into the chat or maybe verbally, because we are at the end for this first session. Okay, so the first question, whether or not it's an information system or a digital twin. So what is the conceptual difference here? Now, there are information systems which should be considered digital twins. Certain ideas, of course, are older than the term of a digital twin. And when you remember that differentiation that we saw yesterday between a twin and a shadow and a model, normally these information systems would be shadows. They display certain aspects of the system based on a live data feed. Now, a factory information system is such a thing. The moment it takes an active role into control, it becomes a digital twin because the feedback goes back in. So in that sense, there might not be a difference at all. However, the digital twin has this aspect to say, I'm mirroring something, and because in that sense, I'm a mirror, I might very well have functionality that allows you to have questions like, what would happen if? Now, an information system normally doesn't do that at all. So an information system is a digital twin on level 3. I'm giving you data. And if it's conceptually built to give you the data about one process, one system or something like this, then I would say the two terms fall together. But of course, an information system could be an integrator over many, many information sources, and then it's very difficult to see what are you twinning in that sense. So the twin would normally be more focused towards one process, but that might indeed be a factory, or towards one system. The most important examples are in this area. So they are often more detailed than information systems. They are less of an integrator and more often I am running concurrently. So that aspect might not be true for an information system at all. It might just say once a day I'm creating a summary report, while the digital twin's purpose is normally be live, run concurrently. So there's a little bit of a difference here. But still, your question is very valid, and you have to understand here that the origin of the digital twin methodologies comes from that area, comes from saying, yes, there are things like production information systems, but come on, something is missing here. We need to make an extra step, and that extra step is turning it more towards life. And maybe in the best of cases, maybe in the things where you should go for, to understand that the digital twin has the same causality than the real system. So if it goes beyond monitoring, if you have a model that you are able to ask, but what if we would give that task to the system? Could it cope? Would it break? Would the production stop? Would the machine overheat? If you are having a system that can handle that kind of questions, true what-if questions, then you have a true digital twin. And that, of course, means you can run simulations, you can analysis of possible futures, and that is way beyond any information system in existence in the, let's say, traditional sense of the word. But also please understand that that level is also only reached for certain digital twins, and other systems are also called digital twins, and they might be, by any definition that you use, also be called such an information system. So yes, partly this is about wording, and in that sense I can only tell you that the differences are mostly in the extent to where it could go, but that there is an overlap between these terms. And that is, of course, partly due to sales. If I have a great information system, and then Gartner Group tells me that digital twins are the new hype, then what will I do? I will tell you that my information system is a digital twin and sell you the same stuff. But digital twins can be more than the traditional information systems had been. So, and then the other part of your question, should the role of digital twin be a priority and a leader in the information system that will be obtained after implementation? Who